All right, y'all. So 2.3 deals with finding the domain and range. So y'all will start out finding domain and range of a graph. Then we'll look at how to find a domain of a function. All right, y'all. So let me give you a few definitions first. Our domain. So when we're looking at a graph, the domain is going to be the set of all x values. Okay, and also the domain is what we call the independent variable. All right, so that means the range is going to be the set of all the y values. And we often refer to it as what we call the dependent variable. So if you're looking like something about your paycheck and the hours you worked, which would be your time, would sort of be like my x values. You can work any amount of hours you want during the week, but your pay, which would be like the y values, it depends on how many hours you work. So that's what I was talking about on that. So what I'm going to do for question one, we're going to look at a graph and find four things on it. So let me put up here for my number one. So y'all, my graph, I got a point at 0, 2. So this is just a bunch of points on this graph. And then I got a point at 1, 3, 2, 4. And then over here, I got a point at negative 1, 1, negative 2, 2, negative 3, 3, and then negative 4, 4. So I got 7 points on it, okay? So let me make this a little bigger for you. All right, so there's four things they want us to find on this graph. For A, they want us to find f of a negative 3. So y'all, let me explain what they want. On this kind of problem, they're giving me the x value. So they want to know what y value has the x value of negative 3. So what y value has an x value of negative 3? So that's what we mean when we say like f of negative 3, okay? So to find that y value, we got to go to negative 3 on the x-axis and see where that point lands and look at the y value for it. So let's go over here. Let's go find negative 3. So negative 3 would be right here. I'm going to go straight up and find the point that falls on that negative 3. So now I'm just looking at that y value. And y'all, if you look over here, the y value is 3. So that means that f of negative 3 is equal to 3. Okay. So y'all, next, they want us to find the domain. Now, MATLAB is going to give us these nice little curvy parentheses. And all we're going to do is put all the X values of these points into our set. So y'all, I'm just going to go left to right on the points. So this first point here, if you look straight down, has an X value of -4. Second point, I go straight down, has an X value of -3. Next point, straight down, has an X value, -2. Fourth point, straight down, has an X value, -1. All right, the next point, go straight down. It's at the intersection, which means it has the X value of 0. Going right, my next point, if I come straight down, has an X value of 1. And then y'all, the last point, if it comes straight down, has an X value of a +2. So remember, the domain is the set of all X values of our points. All right, so this next question will be the opposite of A. So for C, they want us to find any X values for which f of X equals 2. So now they're not giving me the X value. They're telling me that the function value equals 2. And remember, that's telling me that the Y equals 2. That's why we were wanting y'all to get used to this f of X notation. Remember, f of X notation is like a Y. So they're saying what X values have a Y value equal to 2. All right, so we got to come up here to our graph and find 2 on the Y. And remember, anything on that horizontal line going across there will have a Y value of 2. And notice I got 2 points. So the first point, so these will say X equals. So my first point is right here. It has a Y value of 2. If I go straight down, that X value was -2. For my second point right here, also at a Y value of 2. And if I go straight down, remember it's at the intersection. So that X value would be 0. Okay, so first one, they gave me the X. I found the Y value. On C, they gave me the Y value and we had to find the X values. All right, y'all, then number D on this one. For D, they want the range. And once again, they'll give us our nice little curvy parentheses. And y'all remember, the range is my set of Y values. So my Y values are going up. So I'm going to start at the smallest Y value and go up. So y'all, the smallest Y value sitting here, the bottom point, if you go to the right, it has a Y value of 1. My next 2 points here are on the same line. They had a Y value of 2. Now, although there were 2 points on 2, we only got to put the point once, and that'll cover everything that has the Y value of 2. All right, the next point's coming up. If you look, have a Y value of 3. And then y'all finally, the top 2 points, if you look, they had a Y value of 4. All right, y'all, any questions on that one? So this is just getting you used to the X's and Y's being our domains and range and getting you a little bit more familiar with this function notation. All right, y'all. So for our next one, so this will be like our number 2. Oh, let me pull that back down. All right, y'all. So number 2, let's see. This graph starts at 5 right here on the x-axis. Now this is a straight line going to the right with a little arrow. And then it goes to the left. Now remember, these arrows mean this line goes on forever in both directions, okay? Y'all, it's the same 4 questions. First, this one wants f of 2, so I'm going to make this bigger again so y'all can see my graph. So f of 2. So they're giving me the x of 2. I'm going to go to 2 and then find what y value it is. So here's my x of 2. So if I come up, I'm about right in here. So let's see what that y value is. And if I go right, it looks like it's at 3. So that means f of 2 is going to equal 3. All right, B once again wants the domain. But y'all look at this. This graph is going towards the right, so we say it's headed off towards positive infinity. This left side is headed off towards the left, so we say that's headed off towards negative infinity. So when you got a graph like this that's going forever in both directions on that x-axis, we say that the domain of this graph is all real numbers. Okay, and that's just because it's headed off towards the right. Remember, if you go to the right, you're headed towards that positive infinity. And if you're headed to the left, you're headed towards negative infinity. And y'all, it does that on the y-axis too. The bottom heads towards negative infinity. The top heads towards positive infinity. All right, let's see what C's got for us. Any x values for which f of x equals 1. So that would be x equals. So do y'all want to try that? So find me some x values for which f of x equals 1. So remember, they're giving me the y equals 1. So what x values have a y value of 1? Now, y'all, so looks like if I went across at 1 on the y-axis, I'm looking at 2 points where it's intersecting. So let's see what my chat says. So my chat says 4 and 6. And y'all guess what? Perfect. Because this first point hits at 4. The second point, if you look down, hits at the x value of 6. Good job. All right, then my range. So y'all, range is my y values. Now on this range, I can't say all real numbers because the range doesn't come down to any of these negative numbers. Looks like the range is only covering all my positive numbers. So on this range, and remember, the range is the y variable. So we say the range is y. This little bar means such that. So y'all, what do we know about these y values? What's the smallest y value that I have here? So how about, let me ask you this. What's the y value if I'm sitting on that x-axis?
Zero.
Okay, 0, perfect. So remember, 5 is my x-axis, but remember, since I'm on the x-axis, that means my y value is actually 0. And then what do we know about it? It looks like the range is any number that is equal to 0 or greater. So we say y such that y is greater than or equal to 0. Okay, and remember, you have to use the equals because it actually is sitting that on that 0 there, okay? All righty, y'all. So that's the only two we had to worry about looking at graphs. So for the rest of this lesson, we're going to find the domain of a function. So let's play with that. So finding the domain of a function. So y'all, the domain of a function is the set of all x values that produce a real number output. So if I throw my x into that function and I evaluate it, I need to get a real number out of that, okay? Now, there's only two things that we're worried about when we look at the domain of a function. So let me play with y'all a little bit. So this will sort of be a review a little bit. So y'all, let me ask you this. What does 5 divided by 0 equal? All right, so y'all, 5 divided by 0, we call that undefined. That means we cannot divide by 0 because that's undefined. You cannot have 5 pieces of pie if there's no pie to start with, okay? So we're not allowed to divide a fraction by 0. Now, the second thing we're worried about in the real world, can I take the square root of a -4? And y'all, that would be no. Because remember, square roots finds the number times itself that equals the number under the radical. Well, if you multiply a negative times a negative, that would give me a positive. If you multiply a positive number times a positive number, that would give me a positive. So there's no two numbers that I can multiply to make that a -4. So this kind of number, we would actually call 2i. And y'all might have seen this stuff before, but 2i, this means that this is an imaginary number. These are the only two things that I'm worried about when I look at the domain of a function. Now, for this section 2-3, they're only going to worry about this one. They're not going to break the radical stuff out until later on in life, okay? So all we got to worry about in this section are fractions. So if we have a fraction, with a variable in the denominator, then we must exclude any x values which makes that denominator equal 0. Okay, so I'm only worried about fractions. So that means if the function does not include a fraction, then the domain is all real numbers. Well, that means if I don't have a fraction, then it don't matter what x I put into my function, it's going to give me a real number output on that, okay? So remember, I'm only worried about fractions in this section. Now, like I said, later on in life, we'll worry about radicals, okay? So we're going to do a few examples of finding the domain of our functions. So we're going to find the domain of each function. So these will start at 3. So y'all, my first one, f of x equals 13 over x minus 7. So guess what? I do have a fraction. So I'm have to worry about this bottom equaling 0. So to find me what numbers will make this equal to 0, I take that denominator, which is x minus 7, and I actually set it equal to 0. By doing this and solving this little equation, I can find any numbers that'll make that 0, and then I'm going to exclude them from my domain. Now, let me tell you a trick, y'all. Since that x don't have an exponent by it, remember, we would treat that like a 1. And the exponent on the variable tells me how many numbers I got to exclude. So since this exponent is technically a 1, I'm only looking for one number that I got to worry about. All right, y'all, so let's solve this. X minus 7 equals 0. I got one move to do. I need to put that negative 7 on the other side by adding 7 to both sides. So when I do that, my x comes down. That cancels. And then 0 plus 7 on the right side gives me a 7. So that's telling me if I put a 7 here, 7 minus 7 is 0. And remember, 13 divided by 0 is undefined. And there's no way to plot an undefined on a graph. So we got to exclude this 7 from our domain. So we're going to use our set builder notation. Our variable is x such that x is a real number and x cannot equal 7. But y'all, the only number x can't be is 7. Any other number, any other real number, I can plug in for that x, subtract 7, and I'll still get a real number out of this. Okay? So, fraction denominators, all I'm worried about. So let's see what y'all do to this. What if I had a p of x equals 2x minus 5? So y'all, what would be the domain of that function 2x minus 5? So y'all, let me ask you this. Do y'all see a fraction here? Now remember, we said on the other side, if your function does not include a fraction, we said the domain was, so here we go, x such that x is a real number. But I don't have to exclude any numbers because no matter what I put in for that x, I can multiply by 2 and then subtract 5. So I don't have any restrictions when it's not a fraction, okay? All right, y'all. This one's on y'all now, okay? P of x equals, how about x squared plus 9? What is the domain of that function, x squared plus 9? Ooh, y'all a little gun shy today. Hey, do y'all see a fraction there? So it's definitely all real numbers. Good job. X such that x is a real number. Remember, y'all, I'm only worried about my fractions here, okay? Which means I can't give them all to you this easy. So let's throw out another fraction. How about a g of x equals 2 over, oh, let's see what I got here. 5 minus 2x. So y'all, this one does have a fraction. So there might be a number that I put in for that x that makes this thing equal 0. So we got to take the bottom of this fraction, 5 minus 2x, set that equal to 0, and solve for that x. Once we solve for the x, we'll have the number that we need to exclude from our domain. Oh, y'all, two ways to do this. You could subtract 5 from both sides, or you could add 2x to both sides. So most people like me to subtract my 5 from both sides. So if I subtract 5, it cancels out there. Y'all let me let one in real quick. All right, so subtracting 5 from both sides, that cancels. I get negative 2x equals a negative 5. Now to make that a 1x, we divide both sides by negative 2. So y'all, those negative 2's cancel, making that a 1x. Whew, 5 won't divide by 2, but these two negatives cancel, making that thing a positive 5 halves. So since I got a 5 halves, when I solve that for the x, that's the only number that my x cannot be. So we got to exclude that from the domain. So we're going to have x such that x is a real number. And x cannot equal 5 halves. So y'all see this, the only two that I had to do any work on were the fractions. The ones that didn't contain fractions, we automatically said x was a real number, and we're moving on.
We gotta write it as a fraction.
In MATLAB, you got to do the 5 halves, yes, sir. And then usually MATLAB will tell you on the bottom there, if it'll allow you to do them in other ways. But on this one, I'll show you what they're doing. Can y'all see this right here? This is sort of where I got that problem. They're writing all the answers. You're just going to choose A, B, C, or D. Okay. All righty. So let's play with this again. This would be my number 7 here. Oh, let me throw this one at you. How about a P of X equals absolute value of X minus 5? So y'all, find me that domain. Oh, I see. X is a real number. Perfect. There's no fractions here. I can take the absolute value of any number you give me and then subtract 5. So this is definitely X such that X is a real number. G of X equals X to the third plus 4. What y'all saying on that one? Once again, that is definitely X is a real number. Good job. F of X equals, oh, how about on top? I'm going to do an X plus 1. But on the bottom, I'm going to do a X minus 9. What is the domain of this function? And I'll let y'all play with that one. Like, y'all, I threw y'all a curveball putting that X on top, remember? I don't care about the top. All I'm worried about is the bottom. So don't worry about that top at all. All you're worried about is the bottom of that fraction. Remember, the top can be 0 all day long. The only place that can't be 0 is the bottom of that. Oh, there y'all go. That's it, y'all. Because what we would do is set x minus 9 equal to 0. To solve that, we just add 9 to both sides. And we get x equals 9. That means y'all are perfect. X such that x is a real number. And x cannot equal 9. Good job, y'all. So now remember, they might throw that variable up top, but we don't care about the top. All we got to be concerned with is that denominator, okay? So good job. All you actually wrote my such that bar. Good job, Marcella. All right, y'all. So that was 2.3. So what we're going to do now is I'm going to do a few problems from the 2.4 support. Just to sort of get you ready for our Thursday 2.4 college algebra. And this just goes over a little bit of adding like terms and multiplying. So for number 1, they give you a problem. D plus parentheses 31D minus 83. And y'all really, they're wanting y'all to get used to what you're going to do with these parentheses. So our goal is to get rid of parentheses first. So when you see a plus in front of parentheses, we treat that like a +1, and we distribute that +1 through these parentheses to get rid of them. So I would bring this D down. So distributing that +1 through, I would have 1 times 31D, which will stay a positive 31D. And then I would have that 1 times that negative 83, which would make that a negative 83. So when you got a plus in front of the parentheses, they come out and they keep the same sign. So y'all, let me ask y'all this. Can I go further to simplify this? Definitely, Charlotte. Good job, because we do have like terms. So let's add these like terms. Now remember, there's not a number in front of the D, so you would treat that like a 1 in front of that D. So 1D plus 31D would give us 32D minus our 83. Now at this point, we don't have any more like terms, so that problem's done. Oh, y'all try this one. We got a 9D minus 8 minus parentheses 5 minus 6D. Now, we're not worried about the 9D at the moment, and we're not worried about that negative 8. What we got to do is get rid of these parentheses. Now, since that's a minus in front of these parentheses, we would treat that like a -1 and distribute that only through the parentheses that follow. So we're not doing nothing to the 9D yet. Not doing nothing to that -8. But y'all, this -1 will change these signs, because a -1 times 5 makes that a -5. And then that -1 times that -6D will make that a +6D. So y'all notice, plus does not change the signs and they come out. Negative or minuses will change the signs. That went from positive to negative. This one went from negative to positive. And y'all look at this. I got all kinds of like terms on this one. I can add that 9D to that 6D. So let's see, 9 and 6 give me 15D. And then I can add that -8 and that -5. So that give me what, a negative 9, 10, 11, 12, -13. So y'all, we're really wanting y'all to get ready for our 2.4 college algebra. Anything that follows subtraction inside parentheses, we'll change those signs, okay? All right, y'all, here we go. -6V minus parentheses -2U plus 6 plus another set of parentheses 14V plus 9. So this one we wanted to hit you with a little bit of everything, I guess. But this -6V is not inside those parentheses, so we're going to bring the -6V down. So I do have subtraction here in front of these parentheses. So we're going to treat that like a -1 again. And we're going to distribute that negative through the first parentheses. So a negative times a negative will make that a +2U. That negative times that +6 will make that a -6. So once again, following subtraction, these two signs changed coming out. But y'all look at this one. This one's plus. So we treat that like a +1 and distribute it through its parentheses. So remember, positive times positive stays a +14V. And then a positive times a positive stays a +9. All right, so let me start with my V's because they're first. So the -6V will add to the 14V. So basically 14 minus 6 will leave us with 8V. The 2U, there's no more U's here. So the 2U comes down as a +2U. And then it looks like my numbers are going to be the -6 plus the 9. So that's like 9 minus 6, which will give us what, a +3. Y'all, at that point, we do not have any more like terms. So that would be our final answer. So the first 3 of these are getting you used to that distributive property, okay? All right, y'all, so let me play with this number 4. Now, number 4, they want us to start multiplying. So I got -4 times parentheses 7A plus 8B. So still sort of getting you ready for this distributing. Now, we know we're going to distribute that 4, but we also got to distribute that negative. So we're going to multiply -4 times everything inside our parentheses. So -4 times 7A will give us a -28A. And then how about the -4 times the 8b? That's going to give us what? A -32b. Okay, the parentheses are gone. And at this point, y'all, we do not have any like terms. So we're done. Oh, y'all, how about this? 2x times y minus z minus w. So y'all, why don't y'all take a second and see if y'all can figure this one out? Now we'll give y'all a clue. This 2x, you got to distribute that whole thing through your parentheses, okay? Two xy, so minus 2xz. Oh, that is perfect, Hannah. Perfect. Sharita. Ooh, y'all all got that right. Good job. So good job. Y'all distributed that 2x through everything. So 2x times y was a 2xy. Ooh, and y'all got that. Then the 2x times the negative z was a negative 2xz. So y'all got that. Good job. And then the 2x times the negative w is a negative 2xw. Good job, y'all. Good job. All right, so let's play with something like this one then. 9b to the third times 2b. All right, so now I'm getting ready for a little multiplying. So you do have to multiply them numbers. 9 times 2 will give us 18. But y'all, what I'm worried about, what is a b to the third times a b going to give us? And this all goes back to when you multiply variables, you add those exponents. So since this b don't have an exponent, we would treat it like a 1. So for our b, we would add 3 and 1 and make that a b to the fourth. So multiply the numbers, then multiply the variables by adding those exponents. All right, y'all. 6g times parentheses negative 4 g squared h4. So y'all, once again, since I'm multiplying variables, I'm going to put an exponent of 1 by this g out here. Now, this ain't the distributed property because all this is one product. Okay, it's not separated by adding and subtraction. So that's one product. So all we got to do is multiply that 6 times that negative 4. That's going to give me what? A negative 24. The g times the g squared. I got 1 plus 2. So that's going to give me a g to the third. And y'all guess what? The h4 didn't have an h4 out here to multiply by. So we just bring it down and it stays in h to the fourth. So you're only changing the exponent on any of the variables if you're multiplying that variable times itself. Oh, y'all, here comes a good one. 5b plus 3d, 5b minus 3d. So what in the world am I going to do to this one? Y'all remember that fancy little term when we multiply this? So you're pretty close. Think about aluminum. So how about now that FIFO might work, Lord, I've never heard of it called that way. But this is just to let you know you got 4 things to multiply. So y'all, this is like a double distributed property. We're going to distribute the 5b through the second parentheses. Then we're going to distribute the 3d through the second parentheses. So FOIL, first ones from each parenthesis. So notice I'm distributing my 5b. So 5b times 5b is a 25b squared. Then O is the outermost. So that's going to be the 5b times the negative 3d. So 5 times negative 3 gives me a negative 15. B times D is just a BD. Now, the inner is the I, the inner 2. So we're starting to distribute the 3D. 3D times 5B is a positive 15. So D times B, I'm just going to put them in alphabetical order so I can keep up with my like terms. So a D times B is still a BD. And then y'all finally, the L is the last ones from each parentheses. So the 3D times a negative 3D is a negative 9D squared. So notice the B times B gave me this B squared. The D times D gave me that D squared. So y'all, what do y'all notice about the middle of this? It definitely cancels out. So these two cancel. And y'all, let me tell y'all a trick. This 5b plus 3d, 5b minus 3d, they're exactly the same except one's positive and one's negative. These we call these conjugate pairs. So those are conjugate pairs. And when we multiply conjugate pairs like this, the middles always cancel out. Okay, 100% of the time. If it's conjugate pairs like this, one being added, one being subtracted, but everything else is the same, those middles will always cancel. So that means the answer will be the 25b squared minus the 9d squared. And we even got a special name for this. This kind of answer, when you multiply conjugate pairs, this answer is called the difference of perfect squares. Because 25 is a perfect square, 9 is a perfect square, and then the b squared and d squared, those are perfect squares. But we ain't got to know all that right now. All right, y'all. V minus D times V minus D. Now be careful. These are not conjugate pairs because these are both being subtracted. Okay, so since these are not conjugate pairs, the middles will not cancel out. So y'all, let's start foiling. V times V is a V squared. V times that negative D is a negative DV. So remember, I'm just keeping mine in alphabetical order. On the inside now, we got the negative D times V will be a negative DV. And y'all, that negative D times that negative D, a negative times a negative will make that a positive D squared. So if you want to, treat all of these like they got an exponent of 1. Okay. Notice these are the same. They're both negative. So these we will combine as like terms. And they're not going to cancel. So bring down that V squared. So remember, there's not a number here. So it's like a negative 1 dV and a negative 1 dV. Well, negative 1 plus negative 1 will give you a negative 2 dV. And then at the end, bring down your positive D squared. Okay, so conjugate pairs will cancel the middle. If it's a repeat factor being multiplied, then it doubles that middle instead of canceling. All right, y'all. So one more to get y'all ready for me for Thursday. I got a x to the third plus 5 times x to the third minus 3. Y'all also notice the only time I'm changing exponents is when I'm up here multiplying. Once I got down here adding like terms, you cannot change the way things look when you're adding. The only time we can change how they look is up here when we're multiplying, okay? So let's do this. The x to the third times x to the third. What will that give us? X to the 6. Good job. And then notice I got that x to the third times that negative 3. So that's what, a negative 3x to the third. All right, y'all, then you're shooting on the inside. 5 times x to the third is a positive 5x to the third. And then finally, that 5 times negative 3 is a negative 15. All right, y'all, can we go further? Definitely. Good job, because we do have like terms sitting in the middle, y'all. If I would bring my x to the 6 down. Now remember, adding like terms, we cannot change those exponents. All we can do is change the numbers in front. So I got a negative 3 plus a 5. So that'll give us what? A positive 2x to the third. That takes care of that. And then bring down our negative 15. And y'all, at that point, no more like terms. So we're done. So y'all, that 2.4, that's 2.4 review. And it'll sort of get you ready for my 2.4 college algebra coming up on Thursday. So if you want to play with that, you could. If not, you can wait till Thursday and do that with the college algebra either way. Alrighty, also, any questions on that? All right, so I'm actually going to stop our share. And then I'm going to stop that recording so I can send that out later.